About evolution of parallel query, how parallel query works, parallel query parameters that influence how parallel query works, and some of the cost estimation, how the optimizer estimates the parallel query costs. We'll talk about parallel safety, some of the considerations when you use parallel query, and we'll also talk about some of the limitations of parallel query. Over the years, since 9.6 of Postgres version, a lot of the capabilities are getting added. We have constantly added support for parallel hash scans, things like parallel aggregation. More query types have been improved to use parallel query. A lot of performance improvements along the way, and it keeps on improving in different aspects of how parallelism works within PostgreSQL. Let's quickly talk about how parallel query works. So normal queries, when you're not using parallel query, let's call it a serial execution. You have a single process when you issue a query, essentially doing all of the work. So look at this execution plan. You're basically selecting everything from pgbench accounts and you're filtering it. So there is no index on A balance, so it has to basically do a full sequential scan on that table. And then once all of the rows are retrieved, then you apply the filter to just bring back the row which has A balance equal to 10. This is what we call a serial execution. Now, what if we wanted to get this to run somewhat faster using parallel query? This is the architecture of the processes when you have parallel query in action. You will have a gather node, which is the main worker, and then you have multiple workers working together to split up the work. Each of the workers will individually do the work. If it can do some of the sorting, it will do this. If it can do parallel aggregations, it will do it, and send all of the results back to the gather node, which aggregates all that stuff, and then gives it back to your query executor. So let's look at the execution plan for a parallel query execution. So here you can see the same query. When it decides to use parallel query, you can see workers planned and workers launched to be 2. So in this case, it decided to use 2 parallel workers in order to speed up the query. And here you can and here you can see that it says loops equal to 3. So it is the number of workers that it used, as well as the gather process. So that's why it says loops equal to 3. So for that particular node in the execution, you can see that it used 2 workers to scan the table pgbench accounts in parallel, and then it brings back the results to your query, speeding up the results. Let's talk about quickly some of the parameters that influence parallel query. So one of the important ones are max parallel workers per gather. When you have an execution plan, you have multiple nodes or steps in that particular execution plan. Max parallel works. So in a single query, you could have multiple gathers depending on how big the query is and how many nodes you have. So max parallel workers per gather essentially sets the number of workers that each node's gather process can use. Okay. So let's say you have a system with 8 cores, but a particular node has to scan a table with possibly 10,000 records, and there is no point in using more than 2 workers, right? So setting the max parallel workers per gather to more than 2 is not going to improve your query performance by that much, right? And the other aspect to think of is if you have systems with lesser number of CPUs, but a particular node requires 8 parallel workers or 10 parallel workers to scan that efficiently, because let's say you have 1 million rows, then you might start overloading your system because you have only two CPUs to work on, but you have 10 workers to do in your parallel query. So this particular parameter controls how many workers per gather you can have. One of the worst things you can do is to enable parallel query, have a lot of workers, but less number of CPUs, and you're going to become CPU bottlenecked. Whenever a query optimizer tries to decide whether to use parallel execution or serial execution, it applies these cost parameters to decide the cost of a parallel query, and it also calculates the cost of a serial execution, and which one is lower, it picks that for the execution, right? So these are some of the parameters which influence the cost calculations of parallel queries. One is the parallel tuple cost. So when you have workers and the gather process, there is data exchange between these workers. right? So this particular parameter says, what is the cost of exchanging rows between your workers and your gather process, right? And then you have parallel setup cost. Whenever you have, when you compare it to a serial execution is a single process. When you decide to do a parallel query, you have to set up the gather process, you have to start up all the workers, and they need to start reading and processing the query. So there's a setup cost. In a serial execution, it's just that same process executing the query. But in a parallel execution, you have to set up all these and start coordinating. So this particular parameter kind of decides what the initial startup setup cost is. These two parameters determine whether it will consider a table or an index to be used as part of a parallel query. So the default is 8 MB for min parallel table scan size. So if any table is in the query which is less than 8 megabytes, then it will decide not to use parallel query with it. And the min parallel index scan size, if it defaults to 512 KB, and anything lesser than that, it does not become a candidate for parallel query. And these are all parameters you can tweak to influence the way the optimizer picks the execution plan. Parallel leader participation. So the same job that these worker processes do, the gather process can also do. But if the gather job actually spends time doing stuff that the worker should be doing, then maybe it can bottleneck on consuming data from the workers which are part of the parallel query. So often, you don't want it to be doing the job that workers are supposed to do. But in some cases, when you need to return rows very quickly, you can also have the gather process do some of that work. This particular parameter decides whether to use the gather process for doing workers' job. If you want to set up parallel query to work at the table level, this parameter parallel worker. So let's say you have 100 tables in your system, and you only want parallel query to be working on 4 or 5 of them. The rest of it, you don't want parallel query to be working on. You can set parallel workers to a particular number at the table level. These two parameters kind of work hand in hand. The max worker processes is an all-encompassing number, which is the maximum number of worker processes allowed for the entire instance. This includes the parallel worker processes as well as the workers that maintenance processes require, right? So that is like the global cap. And max parallel workers is the maximum number of parallel workers allowed for the entire instance. As Raj speaks through some of the performance considerations, you will see how max parallel workers influence whether a query actually uses the number of workers it's supposed to use. One of the things is that max parallel workers acts as a governor so that your system is not overloaded with worker processes. With that, I'll pass it on to Raj to go through a lot of the cost estimation.
Thanks, Rajeev. So normally, right, whenever you're talking about parallel processing, we want to find out how the cost is being estimated by a serial process and also the parallel process, right? So normally, if you're going to look at a normal sequential process, serial process, where we have two different nodes. One is like a sequential scan, other one is an aggregate, and we have a cost factor, which is like a startup cost and the final cost. Let's look at how the cost is being calculated. So we have a total cost for the calculation of the sequential scan and also for the aggregate together. And obviously, right, we have a CPU sequential page cost, CPU tuple cost. These are the costs are going to be like a generic for any type of query what the optimizer kind of uses. And this is a simple calculation. I kind of put it together in a SQL format where we'll be able to estimate the cost of a single query. Now, if you look at the parallel processing, right, there's a multiple different steps or components being involved. Normally, we have to do a parallel sequential scan. All the workers does the sequential. And then every worker kind of aggregates too, which is called as a partial aggregation. It means every worker basically scans a couple of rows and then count the number of rows. And then it kind of gives you the gather, and gather also to the final aggregation. So multiple different steps. And if you're going to look at the cost estimation, right, these are the different type of steps where the cost is being used. When you look at the cost of gather, right, that's the only difference between the serial operation, where you have a parallel setup cost and parallel tuple cost. Remember, Rajeev was talking about these are the two tuning parameters where you'll be able to tweak it to make sure whether you want the optimizer to use favor the parallelism or not favor the parallelism. So pretty much actually you can able to manipulate these two costs to see how the results you wanted to see. So this is going to be another big query. because it has got a multiple nodes. It's another big query where you can able to get the final cost and whatnot. So we'll be sharing the slides, but I just want to show how you can able to calculate between the serial and the parallel execution. Yeah. No, this is just for a calculation of the costing, just for the calculation of the cost. Next comes to the parallel safety. So normally, right, whenever you're going to be creating a function, and if you're going to be using the function in the SQL query, sometimes it doesn't go through the parallelism. Because the reason is, right, there are 3 different ways the function can be configured. I'm talking about the user-defined function. It can be a parallel safe. It means this particular function can be used in a parallelism. Or parallel restricted. It means the normal leaf node cannot use the parallelism, but only the top gather node. Or parallel unsafe. It means whatever the function you're using, it cannot use parallelism at all. Normally, when you create a function, simple function, say I'm just kind of converting integer to a varchar. When you look at the pgproc table, it's going to show the parallel is unsafe. It means any user-defined function you created for the first time, Postgres kind of assumes that is a parallel unsafe. What is the implication of that? Whenever you're going to be executing the query, it will not go for the parallelism at all. It means when we're doing a select convert to varchar to whatever, the same query was executing parallel before. Just by introducing a simple function, it avoids the parallelism. But if you know exactly what the function does, it's not going to be implicating anything, then you can convert the function to the parallel safe. It means if you know exactly what the function does in terms of running parallelly, it's not going to mess up the result set. You can convert the function to parallel safe. Then, if you're going to run the same execution plan, you'll be going to the normal parallelism. So these are the one thing which, especially when you're dealing with the user-defined functions, you have to kind of consider this one. Sometimes, right, you'll not be able to convert all the function to parallel safe because the reason is, right, each and every worker is executing it separately. Every is a separate worker process. So you want to make sure that whatever they're getting executed, it kind of works in a serializable fashion. And also there's a parallel index creation. So normally, right, this is a couple of different parameters, max parallel maintenance workers, which Rajeev was talking about. And currently, the Postgres 17 supports B-tree and Brint indexes to be executed in parallel. Whenever you're creating an index, you can be able to use the parallelism to build the index faster. So a couple of examples which I showed here is, suppose if you're not using the index, if you're not using the parallelism, it takes like 17 minutes. If you're going to be using a 4 max parallel worker process, it takes like 9 minutes. Don't go under the impression that double the parallel worker will be like off the time. So it's not going to be linear propagation. It means at a particular point in time, it's going to get saturated. So obviously, the number of parallel processes you're going to throw at the system, it's not going to get translated into the timing. And also, there's a parallel vacuum. So there are 2 different parameters, parallel maintenance workers and the max minimum parallel index scan size is going to decide when to use the parallel vacuum. So normally, right, whenever you're executing that vacuum on a table, it goes to a couple of steps. First, actually, it's trying to understand it's going to scan the heap of the table. It's going to go to each and every index and identify the heap. Then it's going to do the cleanup of the index and cleanup of the table. Normally, all of the processes are going to be sequential. Say, for example, if you have 10 indexes on a table, everything is going to go sequentially. Obviously, it's going to take a long time. So instead of that, we can able to have a new parameter called vacuum parallel for with a verbose. So what it does is, it's going to go through the scan of the table sequentially, but all the indexes in the table will be able to run parallel. Okay, so normally what it does is, it's going to invoke the number of parallel process, which is nothing but number of indexes minus 1. The current table, I have 3 indexes, so it basically uses the planned worker as 2. So this is one of the way in which you can be able to improve the performance of the vacuum process by analyzing the indexes in parallel. So far we talked about all the different type of parallel query parameters and whatnot, right? Let's look at what are the different considerations you have to do, especially dealing with the parallel query. So this is the first thing which you may be coming across. Whenever you do an explain analyze, right, there's a 2 different components of it, workers planned and workers launched. What is workers planned? whenever the optimizer kind of thinks, okay, I have a parallel sequential cost, I know what is a parallel tuple cost, putting everything together, okay, this particular query can use 2 workers. That's what the optimizer thinks. But when the actual query runs, it basically gets 0 process. It means this particular query is being executed sequentially. Because if you look at the number of loops, right, it's 1. The reason is, as you know, right, the maximum parallel worker process is set to 8. If the same query is run by multiple different sessions at the same time, every parallel worker process being occupied. It means all the parallel worker process being used by the different query. So this query was not able to get the exact parallel worker process what is needed. So the reason is, right, so it means you have to kind of understand yourself like, okay, how many times I'm executing the query, how many parallel sessions are being executed the query. Based on that, you have to come up with a proper number of the maximum parallel worker process. Obviously, right, you'll not be able to set 100 because if you're going to be running in the CPU, you're going to run into performance issues. So it's kind of a balance between. That's the reason, right, we want to highlight like not all the queries can be run in parallel. You don't want to run every query in parallel. Some of the large tables can, some of the overlap query you want to make it parallel. But if it is kind of a OLTP, kind of a single looking transaction, better to run in a serial fashion. Oh, sorry.
Is there a session where we can turn off?
Yes. All the different parameters, whatever we talked about, all can be set in a session level. Say, for example, if we can set minimum worker per gather at the session level, page cost, and all other cost, everything we can at a session level. And some other consideration, right? So Postgres, everyone know, like it's a process-based system. It's not a thread-based system. So if you're going to be invoking multiple parallel worker process, everything is a separate session connected to the Postgres. It means it's going to have a work memory allocated to it. So another thing is, right, there is a multiple different parameters we talked about, parallel setup cost, parallel tuple cost. All of them you can be able to tune it to see whether you want to enforce or you don't want to enforce the parallel query. Another one interesting which we come across like a JDBC client issue. So normally what happens is, right, whenever there is a libpqr protocol which you're using like a pSQL or pgadmin, basically it does not send anything like a non-zero fetch count. But any driver which is using a JDBC, especially a DB viewer type of client, it basically sends the non-zero fetch count. If the non-zero fetch count comes, the Postgres parallel query does not get executed. So you just have to go and modify the client to send the non-zero fetch count to 0 so that it understands. So this is kind of a limitation from the parallel query side of it. If it receives any additional variable from the client, it does not get executed. And also there is a pgstat activity. We have 2 different parameters which is there in the background which we're able to monitor how the execution is happening, whether the leader node or what different type of backup type. So you can able to monitor the execution of Postgres, number of parallel processes in your system. And also, right, I think we are talking about the same thing. More workers may not translate into the better performance. Obviously, there is some kind of a limitation where the number of worker process, what you are executing it, may not get translated to the results what you wanted. So kind of come to a proper balance. And there are ways in which you can able to monitor it. One is you can able to do an explain plan. I think we have been doing it so far. Better to do explain, analyze. The reason is explain will give you the workers planned. Explain, analyze will also give you what is worker being used. So basically it executes a query and give you the answer. So try to do with the explain, analyze. And also you can able to check the pgstat activity. Try to figure out how many background process parallel workers are being running it, or is it all of them are active, or is being used, or whether do you want to increase the number of parallel worker process. So all of information you can get it directly from the pgstat activity. Then also for the index, right, we saw about the parallel index. You can look at the pgstat progress create index to see. And obviously, right, by enabling the logging, you'll be able to have additional information about how the parallel query process is working. And we started with the 9.6 version and up to 17 version, right? So there is a lot of limitations with the older version, but we are in the process of removing the limitations over a period of time. But there are still a couple of limitations, especially when you are dealing with the DDL statements, the insert, update, delete, parallel query will not be getting executed. And also, if you have a multiple subqueries, only one query will be able to do the parallelism, not the main query. And also the system-defined function. Look, we saw about the parallel safe, right? So if you are going to be using some of the functions, or if you look at the pgproc table and look at all the system functions, some of the functions will be parallel safe, some of the functions will be parallel unsafe. So it means if you're running a query, if you're using even the system-defined function, if it's not using a parallel query, you can just check at the pgproc table. And also, right, if some of the background worker process is already allocated, will not be able to use it. And if you're going to be using a transaction isolation set to serializable, parallel query will not be able to execute. So either you have to set read committed or repeatable read. So in a conclusion, if you want to execute, if you want to use the parallel query by utilizing a multiple CPU cores, definitely can able to look at the parallel query option. And obviously, one of the main use cases, if you're going to do a large table, large sequence scan or OLAP type of query, which is going to be running like multiple different tables, joining, definitely it's going to benefit. But obviously, it has limitations too. It means since we have a limited number of parallel workers and all the queries will not be able to use the parallelism, so better to kind of stick with that one with the proper use case scenario. Then you have a couple of tools for you to tune it, like parallel tuple cost and sequential tuple cost and setup cost. There are a couple of parameters we can able to play with, but to enforce or not to enforce the parallel query. And also, right, as I mentioned, we started with the 9.6 version, currently 17 and 18, but definitely the improvements are being implemented over the period of time. So definitely there is a lot of scope of improvement, and it's being worked on. And thank you very much for your time. And there's a survey link. If you can please provide our feedback, really appreciate it.